Assalamu alaikum. My name is Soyed Istiak Raja. In this video, I will try to explain how our Team Red Hill, made the program counter in 6-bit computer project. I am in the parent sheet of SAP project. So you will see the program counter. There is 4 input pin. The first one is CO, counter output. Second one is counter enable. Third one is reset, and fourth one is clock. So uh, the first two input came from the controller sequencer. So counter output uh, decides whether the output of this program counter should go to the bus or not. So the counter enable pin give the JK flip flop the logic high input, and the reset pin is to reset all the input on the flip flop, and the clock is to give clock pulse to the flip flops, and clock is generated from the clock pulse generator. So now I am going to the child sheet. So I am now going to the child sheet of this program counter. So you will see the 4 pin here, and this 4 pin is connected to a input console. So input console is to take input from is for the PCB. When we will made other components for PCB, all the out, outputs or other pins from like counter output, clock, counter enable, these all inputs will came from other PCBs to this input console, and this power block, this T block is to power all the components in this program counter. And there is you can see all the capacitors. There is 3 4 5 capacitors. These 5 capacitors uh, is uh, is connected to 5 ICs in the PCB. There is 5 components used in our SAP. One is for this NOT gate, 3 flip flop, 3 4, and another is for this 2 NAND gate. So 5, there's 5 component 5 ICs in the PCB. So if there is any unwanted frequency which will cause any harm to the PCB, so we connected capacitor parallelly to all the ICs that will get current from this power. So we connected this. So this input and power is only for the PCB portion, but for the main theory portion, we'll first go to the theory part. I take this screenshot from All About Electronics. So there is uh, this is a synchronous 3-bit up counter. So there is 3 flip flop inside it. For the first flip flop, all the 3 flip flops is connected to a positive S trigger, and the first flip flops input J and K is logic high. So the output, if the output is 0, then for logic high, this output will be toggled and will be 1, or if this is 1, then it will be 0, as we know for the JK flip flop. And when the counter output, when the first flip flop output is 0, uh, the second output will be, and second output is 0. So when the first output is 0, the second output is also remain the same. But when the first first flip flop output is 1, the second flip flop output will be toggled from 0 to 1. Again, here you can see 0, so it will remain the same. Again 1, it will be changed. Again 0, it will remain the same, and again 1, it will be changed. So the third flip flop is connected with a NAND gate from the second flip flop input and output. So this second flip flop input is same as the first flip flop output. So first flip flop output and second one's output is connected to a NAND gate, and then to the JK input of third flip-flop. So this one means when this both is 1, then it will get the 1. So when Q1 and Q0 is 1 and 1, it will be 1, and the Q2 output will be toggled. So Q2 output was 0, and when this Q0 and Q1 was 1, Q2 is toggled again. Here when this 2 is 1, then this 1 is toggled to 0. That's how a synchronous 3-bit up counter works. So in the diagram portion, you can see there's 3 flip-flop. There is counter enable pin, which will be active high when I will give 1. It will be 1 and 1 here, and the 1 is also going to here with a AND gate. It's connected to the output. These two output will be the other second flip-flop's input. This AND gate is not necessary, but this AND gate is necessary. For the second flip-flop input, as we mentioned in the theory portion, this AND gate is connected to second flip-flop's input to the with the second flip-flop's output, and it's connected to the third flip-flop's input. So this is the 3-bit counter portion. This is an up counter. All the outputs is this one, and for this 3 flip-flop, this is the least significant bit and this is the most significant bit. So this 3 line is going through a tri-state buffer. This tri-state buffer is controlled by the counter output portion. As we know, this one is active low input, so we connected a NOT gate in it. So when it will be 1, it will be 0 from this NOT gate, and it will be on. The all the output from the flip-flop will go to the bus from this tri-state buffer. And this reset pin is also connected to a NOT gate, because all the flip-flops reset pin is active low input. And here also there's the question that why this NOT gate is connected to the clock portion of this flip-flop, because you can see this is a negative flip-flop, but on the theory portion we see this clock is positive S. So we connected NOT gate to the clock, and this NOT gate will make this negative S flip-flop a positive S. This is an output T block where we'll connect the display output. That's how this program counter works.